Alright, this is lesson 5 for 8th grade, and today we're talking about fractional parts. And this should be a review for my 8th grade students. We've talked about it last year in 7th grade, probably started to talk about it in 6th grade. We're going to start very basic today, not nearly as much as we're going to do with fractions in the future.
Jacob Womet, please come to the middle school office. Jacob Womet to the middle school office now, please.
Sorry about that. So we're going to jump in, and like I said, it starts very basic. They even point out what the denominator is, what the numerator is. Numerator is our top number, denominator is our bottom number. Easy to remember, it's the one that's down. It starts with D, denominator is the one that's down. The denominator stands for the number of equal parts that we have, and then the numerator is how many of those equal parts we're talking about. So this would be 1 out of the 3 parts. So we started off with a question here. There were 30 questions on the test. 1/3 of the questions were true-false, and 2/5 were multiple choice. How many questions were true-false? Okay, well, let's figure this out here. We've got 1/3, and it says 1/3 were true-false. Okay. So, to me, that says 1/3 of them were true-false. And that's 1/3 of a total of 30. 1/3 of 30. Now there are many ways to go about and solve this question. The way I like to start off showing it before we get into fractions in depth is this. We've got three equal parts.
Jacob Womet, please come to the middle school office. Jacob Womet to the middle school office, please.
We have 3 equal parts, and we know that all 3 of those together make 30. Okay? So if all 3 of the parts are equal, we take 30 divided by 3, and we get 10. That means 10 goes into each of these boxes. 10, 10, and 10. And notice how if you add up all the boxes, you get your total. So that's what we wanted. And we are talking about 1 out of the 3 boxes. So that's just 1 of them. This is 10. 10 of them were true and false. Okay? Another way that this could have been done. I remember we should be getting 10 still. 1/3 of 30, my students should remember that of is a keyword in math, and it means to multiply. So, 1/3 times 30. Okay? Now 1/3 times 30, maybe they don't know what to do with that right away. What I like to tell them is that we can put 30 or any number, and we can turn it into a fraction. We can put 30 over 1, still means the same thing. And then it becomes a little more clear. Here's that, times 30 over 1. And what we can do is multiply straight across right away if we want. 1 times 30 is 30. 3 times 1 is 3. And we see we have 30 over 3, or 30 divided by 3, we'll still get 10. Now, one other way that they could have done this with this same format or setup is they could have said, okay, well, I know instead of multiplying across, I know that 30 and 3 are going to cancel out eventually. So I know that 3 goes into 30 10 times. So we just divide by 3 with 30 and 3. 1 times 1 is 1. 1 times 10 is 10. 10 over 1 is 10. So we still get 10 no matter what. Just another way to do it. We could use any of those same setups to figure out B, how many questions were multiple choice. And it says 2/5 for multiple choice. Alright, I'll set this up the same way as that one. 2/5 of 30. Okay, we could go back to the box situation if we want to. We've got More to fill this time though. We've got 5 boxes, so it's out of 5. 1, 2, 3, 4. They don't look very equal, I apologize for that. But let's imagine that they are. And we know that the total questions is still 30. And we are going to be looking for 2 of these boxes. But first we got to figure out what each box is. So we're going to take 30 divided by 1, 2, 3, 4, 5. Should get 6. So 6 goes in each box. Okay. And now we're talking about 2 of those boxes. So 2 will be 12. If we add those 2 boxes together, you get 12 multiple choice questions. And real quickly, I'll show you the other way to do it. If we use multiplication, 2/5 times 30 over 1 equals. Alright, now I could multiply straight across if I wanted to. 2 times 30 is 60. 5 times 1 is 5. So we would have 60 over 5. We could do 60 divided by 5. We would get 12. Or we could do our shortcut. Where we do? Okay, I know that 5 goes into 36 times, so we'll divide by 5. 1, 6. 2 times 6. 12 over 1. We still get 12. So, those are all the ways we could have done that one. Alright, moving on. I won't do all the ways to do this one, just one way. There are 35 students in a class, 2/5 of them are boys. How many boys are there? Well, 2/5 of them are boys. So that's 2/5 out of 35. I'm going to do the multiplication way. If you want to do the box way, that's fine. So 2/5 times 35 over 1. And we get, if I use my shortcut here, 5 goes into 35 7 times. 5 divided by 5 is 1. 35 divided by 5 is 7. Now we have 2 times 7, which is 14. And 1 times 1, which is 1. 14 over 1, 14. Should get 14 boys in the class. Next question. Okay, so how many girls are there? Well, let's take the shortcut here. We have a total of 35 students, and we know that 14 are boys, so the rest have to be girls. Well, let's just do 35 minus the number of boys. We get 1, 2, 21 girls. Okay? Next, ordering from least to greatest. This is an easier way to do it. The larger your denominator, in this case, the smaller your fraction is going to be. So 3/8, 3/6, 3/5.
Anthony Escobar to the office, please. Anthony Escobar to the middle school office.
Alright, one other way we could have looked at this, 3/8, that is less than 1/2. 3/6 is 1/2. 3/5 is larger than 1/2. So, this is our smallest one, middle one, and largest one. There's 2 ways to do that. And our last one here, 2/3 and 2/5. 2/3. 2/5. Which one's larger? Well, we could use the same tools as the last problem. I know 2/3 is bigger than 1/2, and I know that 2/5 is smaller than 1/2. So 2/3 has to be larger than 2/5. We will come up with other ways of doing this, getting common denominators and such, but we're not there quite yet. They have learned about that, but we're still doing some review. So for now, we're going to use this method, and we'll just progress. So we'll see you next time.